Have most of these sessions so far started on time, or do people hang around waiting? Yeah. What, is it past by most people's watch? A minute still to go. Oh dear, okay. So, does anybody mind if I take their photograph? Are any of you pretending to be off sick at the moment? It's just that my family keep asking me what the hell I do. And, you know, sometimes it's just good to show them a photograph so I don't have to talk to them anymore. Great. Thank you very much. So, I am going to start, and if people come in, I guess they come in. This talk is entitled So Long and Thanks for All the Tests. My name is Seb Rose. I'm a developer of long standing. I started back in the dim dawn of prehistory on Apple IIs. The first program I ever wrote was actually on a PDP-11 64. So, you know, I go back away, and through my career, I've done a lot of developing. I've learned a lot along the way. Almost none of it was taught to me at university. And I think that's typical of many developers. You do a lot of theoretical work, and then you get let loose in the real world, and it really depends where you end up and who you end up working with, what you learn. I do a lot of this talking these days. I do consulting for companies. I go in and help them with TDD, unit testing, behavior-driven development, but I also go into companies and look at their so-called agile processes and make considered comments about them. This talk's not about that. This talk's about tests. So you're all here. I guess you've read the description that's in the pamphlet. Are people familiar with where this quote got ripped off from? Hitchhiker's Guide to the Galaxy, yep. So Douglas Adams, strange screen. Douglas Adams wrote this book, So Long and Thanks for All the Fish. But like so many things that Douglas Adams did, it was a reworking of something that he'd done earlier. So it's a quote out of the first book, which is Hitchhiker's Guide to the Galaxy. And the quote is, in fact, "The last ever dolphin message was misinterpreted as a surprisingly sophisticated attempt to do a double backward somersault through a hoop whilst whistling the Star-Spangled Banner. But in fact, the message was this: so long and thanks for all the fish." Now, I didn't start off with this as a title, but I started thinking about, I'd seen a lot of people talking and blogging about unit tests, about how they caused so much problems, they never delivered on their benefits, how they slowed you down, they didn't give you any help at all. And so I started wondering why that was. And it seems to me that quite often we get confused between writing tests and specifying what the code's supposed to do. And I think that quite often our software doesn't appreciate the tests that we've written. Partly it's because of the way we write the tests, and partly it's because of the way we write the software. And so this session is an exploration of some of the reasons why I think things go wrong, and some hints, or at least my learnings about what I think you need to do it right so that your tests actually help you deliver better software. But before we get really started, I want to have a little competition because, you know, I need people to pay attention and think about things while we're going through. Has anybody watched this talk on any of the streaming services? No. Because if you have, don't try and answer the question because you already know the answer. So the competition is this. Can you name the cult trilogy from the 1970s that includes a talking porpoise guiding a submarine to Atlantis? So, you can? No. No, that's not a trilogy, I don't think. So anyway, there'll be a clue later on. It's a good try. Very good try. So anyway, that's the competition on the back. Nothing to do with Hitchhiker's Guide to the Galaxy, but I thought since we were talking about porpoises, it was a relevant sort of competition. So why do we test software? Anybody? I mean, let's start off at the beginning. Do you test software? Why? Oh, you're a great coder, aren't you? Surely it works.
Make sure it keeps working.
To make sure it keeps working as well. So, Gerald Weinberg wrote this brilliant book. I don't know if you're familiar with him. He's a very humorous and very well-respected consultant. And this is one of his funnier books, where he talks about where testing fits into the hierarchy of software development. And he talks about testing being the process of gathering information about software with the intent that the information could be used for some purpose. And he goes on quite a lot of length about the fact that you have to use the output from the tests to do something. And so a lot of people do tests and then ignore the output. I lose count of the number of places where I go in and they've got a continuous integration server running. I say, can I see your build output? And they go, yeah, it's red. Yeah, but some of those tests always fail. Right? I went into one place last November and they'd been red since May. Right? I went into another place the week before last and they turned them off a year and a half ago. So this is not, it's not theoretical, it's not speculative. This actually happens. People do testing and then completely ignore it. So, but there's lots of testing. There's acceptance testing, there's performance testing, there's load testing, there's usability testing. What I want to talk about is developer testing. So I guess my presumption is that this is a conference called DevWeek. I'm talking about unit testing. I think we're all developers. Is there anyone here who isn't a developer? Okay. So when do you write your tests? I'm going to put up a number of options here. And if you could put your hand up just to indicate when you write your developer tests. Never. So, I mean, don't be embarrassed. There are a lot of people who what they do is they write the code and then they run the application, they try it out a few times and do things. They don't write unit tests at all. Everybody here writes? Oh, there's one person that's not too shy to put their hand up in the back. So that's the typical way. Sometimes you will litter the code with print statements, so you'll have a look in your log file and you'll do things like that. But most people here are writing automated unit tests. Yeah? Good. When do you write them? Do you write them once the code's working? Okay, that's prevalent. Okay, fair enough. Do you ever find that the code's hard to unit test once you've written it? Yeah, okay. It's a beast. So does anyone write the code sort of around the same time as the tests? Uh-huh. And how many people are writing the test before they write the code? Okay, a few. So I mean, this is obviously, we know what this is called. What's this? Well, so this is really test first, because then the final thing is, do you drive your development using tests? And that's where TDD comes in. So how many people are who actually driving their development with the tests they're writing? A smattering. Okay. So I'm gonna boost through this. If I go too fast, slow me down. If there are questions as we go through, just stop me, and we'll sort it out there and then. So test-driven development, I'm going to give a very brief introduction, simply because some people obviously aren't working in a test-driven way. Test-driven development became popularized by Kent Beck, who's one of the fathers of Agile, who wrote this book, Test-Driven Development, and it's in purple, by example. And that's a really good title for a book, because test-driven development is about writing examples to drive out your development. It's thinking of tests as examples. Now, one of the downsides of this book, and one of the downsides of Kent popularizing it and making it really famous, is that we've been burdened by the fact that it's called test-driven development. And test-driven development has, the fact that the word test is in there has turned developers off for about 2 decades. Because we're not testers, are we? No, the testers do testing, we develop. So it would be really nice if it was called example-driven development, because that's really what he's talking about. He's talking about thinking about how your code is going to be used, writing a test that makes it work in that way, and then inserting that it behaves in the way that you expect it. So you're specifying how the code should behave, and you write that specification before you've written the code. He goes on to say later, this was actually not in the book, but he says he gets paid for code that works. And he said this in response to people going, if I wrote all these tests and did Agile in the way that Agile asks me to, I'd never get any work done. So what he says is he gets paid for code that works, not for tests. So he agrees, we're here to deliver software. It's software that our customers want. So he tests as little as possible to reach a given level of confidence. Now this is quite important, this level of confidence, because your level of confidence, or the level of confidence you require, depends on the software you're writing. So if you're writing a noddy game that you're not charging people for and you're going to put it out for free on some app store, well, maybe it can crash every now and then. What could possibly happen to you? But if you're writing things that take astronauts into outer space or run life support systems, you will want to be slightly more confident than that, and you don't want it to crash. So what Kent is basically doing here is saying you want to write tests, you want to be confident in your software, and the confidence is specific to who you are and who you're writing for. He goes on to say that he suspects that he needs to be more confident about his software than most developers. So I don't know, have any of you ever released a piece of software that got into QA or UAT and then they came back with a defect? Yeah, of course, we all have. So, but there are some times when that's not acceptable, and in some cases, some of our defects will have made it to production. It happens. That's why we have all these wonderful ticketing systems where we can get information in. Of course, some defects are requirement defects, and we're not talking about that today, but that is another way things can get into production. So there's nothing to TDD. There it is. It's really simple. You actually start here, you write a failing test. The test runs and is read. Now this read could be because you haven't written the code yet, so it fails to compile. Or this read could be because you've written some code and yet you haven't implemented the functionality that you're specifying in your new test. And then you do something to make it pass, which is write some code. Canonically what you write is the simplest thing that could make it possibly work. I haven't referenced it in this slide deck, but there's a wonderful article by a guy called Robert Martin, also known as Uncle Bob, where he talks about transformations and how you can write the most simple piece of software to start with and then iteratively make it slightly more complex. So if you're interested in that sort of thing, the transformation priority premise is what he called it, rather grandly. Anyway, so you write very simple code to make your test pass, and then, and this is an important bit that a lot of people miss out, you refactor. So you may have done something really dirty to make it pass. You may have copied some code, you may have used a constant where you should have used a variable, you may have taken the first thing from a list instead of sorting or searching through the list. So you refactor here to make your code better, of production quality. And when you're happy with it, you go and write another failing test. So here what we're doing is we're iterating, we're developing our software one specification at a time. And there are lots of problems that people have when they're trying to do this, and if you've tried it and you'll have experienced it, it's like, well, which test do I write first? And what code should I write to make it pass? And how much refactoring should I do before I move on to write the next failing test? And those are questions that there are general answers to, but really the answer is you have to practice. Sorry. Quite a few years ago, another Londoner, a guy called Keith Braithwaite, came up with an exercise which he popularized at the local SPA conference, which was run by the BCS annually. And he called it TDD as if you meant it. Right? So already people are abusing TDD, and he's going, no, let's do it really seriously. And so step one is write exactly one new test. So TDD is supposed to be like that. And it should be the smallest test which seems to point in the direction of a solution. So that's standard TDD. You have to run the test to make sure it fails. So this is actually also part of standard TDD and is often missed out. If you write a test, you must run it to make sure it fails. Because one of the things that we've all found out when we've tried working in a TDD way, a test-driven way, is you write a test, you think you've written the right test, and then you write the code and it passes. And only later do you find that actually the test you wrote was defective in some way. So the problem with doing anything where you're saying, I'm writing code to verify code, is that if you've done something wrong in your verification and then you do something wrong in your implementation, that you don't get any feedback, or at least you don't get the feedback you expect. So what we'll do is we run the test first to make sure it fails, to make sure that we are specifying something that doesn't yet exist, and the failure shows us that it doesn't yet exist. So in fact, in that red section, quite often what I find myself doing is I write the tests, and I run them, and they fail because I haven't created the class, or it's calling a method that doesn't exist yet. Then I write the method that doesn't exist yet, so now it exists, but I don't give it a correct implementation. So then I run the tests again to make sure it still fails, and then I put some implementation into the method and make sure the test passes. So an important step, step 2. Step 3 is make the test pass. So we've talked about that. Now here, in TDD as if you meant it, you have to use the least amount of implementation code as you can, but you do it in the test method. So what you're doing is you're actually writing your implementation in the test method to make sure you're not making use of anything else outside of it, and then you refactor to remove the duplication. So this is a step that you don't do in normal TDD. You wouldn't typically do your implementation in your test method and then refactor it out. And the reason he's forcing us to do this is to try and focus us down on doing the minimal implementation, as little as possible to get the test to pass. And down at the bottom, he says, only introduce new abstractions when they will help improve the design of the code. So here, this is where the second D, test-driven design, the second D is coming out of TDD. He's forcing us to think about the design of our code as we implement things to pass a test. And specifically, only extract a new method if there is sufficient code duplication. So are people familiar with the solid principles? So again, if you're not, then Google them. It's an acronym, again, popularized by Bob Martin. And also there's a book, Pragmatic Programming, which talks about DRY, which is do not repeat yourself. And so here, this is what we're talking about. We don't want duplicated code, because if we duplicate code, copy and paste code, maybe we've copy and pasted a defect. Or maybe the requirements will change, and then we have to go and find all the places it's been copied and modify it again. So only extract a method if there's sufficient duplication in the test method. So basically, how smelly is our test methods getting? How bad is our implementation? And finally, only create a new class when a clear grouping of methods emerges. So this is where the solid principles kick in. We're looking for classes that are small, that have high cohesiveness, which is the operations, the methods on them belong together. And we're looking for low coupling. So we don't want them to be dependent on 40 other classes or interfaces in your system. So these are design principles. Again, these are things that you can read about elsewhere, but you'll need to practice them, because typically, the first time people come to coding, they work in a very imperative way. You write a method, and it's like writing a story, and you start at the beginning, if this, then that, and before you know it, you're 5 levels deep with if and else statements. So these are design principles that come from classic object-oriented design and programming that try and make us think about the interactions between our objects and how we ensure that our objects sort of conform to some abstraction from the business domain. Step 5, repeat the process. So it's just the TDD loop, just made a little bit harder. It's a training exercise to try and get us to understand and feel the pain of why we're doing it. So how many people, so we put some hands up about who's doing TDD at the moment, and it was half a dozen of you. Have many of the people who've tried many of the people who aren't doing TDD tried TDD and found it difficult or impossible? No? Some? Okay. So TDD is something that's been around in XP, one of the original agile methodologies for must be 15, 16 years now. And yet there are objections to TDD. People just won't do it, developers won't do it, managers won't let people do it. And I did a survey online 2 years ago, just asking people, why do you not do TDD? What objections do you have to it? And it sort of split out into, there was no one reason. It was a mixture. There are people who thought they hadn't been taught how to do it. There are people who thought they didn't have the time to do it. There are people who were unsure that there were any benefits. People that said it wouldn't work on our project, and people who said it won't work in our organization. And those, they're fairly typical, they're breakdown, I guess. These are the sort of quotes I had. Takes too much time to write tests. So at this point, I have to say, if you don't write them when you're writing the code, when you're going to write them, and if we all agree that our level of competence needs to be met, we have to write them at some point. So this seems like an odd thing to say. If I change something, it will break a whole bunch of tests that I will have to fix, and it will be more work for me, and in the end, blah, blah, blah. So this is only partially, I only partially want to ridicule this. Because in reality, if you write your tests badly, and you end up with thousands and thousands of tests that all repeat the same, all have specific incidental details in them, and then you get a requirement to change your actual implementation for very good business reasons, you can find yourself having to change thousands of tests. So there's a lot of literature about how to write good unit tests. I've got another session all about that. I do training on it, but there's loads of books online about it as well. And we'll cover a couple of the things to think about in a wee while. Also at this conference, I believe Roy Osherove is here, and he's got a lot to say about this. Running the tests takes too long. So this is a real issue. So we're talking about developer tests here. Developer tests should be components in isolation. They should be fast. They should be blisteringly fast. They should be so fast that you can run them every time you type a character. And there are tools that sit around. I don't know if you're .NET or Java developers, but in .NET land, there's NCrunch, which will integrate with Visual Studio, sit in the background, watch you type and save things, and every time you modify the code, it runs the unit tests and gives you instant feedback. That's how fast the test should be. So that's not a great answer either. No scientific proof of it actually having any benefit. So this is always difficult. In all areas of agile endeavor, people are looking for proof that it's going to work. So there are case studies, it works over here, but it doesn't work over there. A guy called Nagapan, who worked for Microsoft, has done a lot of research into the effectiveness of TDD, and he shows, or he's found that out of the sort of 6 to 10 project teams in various organizations that he's looked at, it's improved the overall efficiency of the team by between 10 and 50%. So, you know, that's significant benefit, and there's a significant amount of research behind it. I encourage you to go and look at his papers if you're interested in taking that further. Here's a good one though as well. It's not practical for the kind of work I do, by which I mean it cannot be conclusively shown to provide tangible benefits that outweigh the perceived costs. So it's the same area. My environment, just it's not going to work here. No one's proven it to me. So we talk about TDD, and I'm talking about driving the design out with the tests. Where does architecture and design fit in? What does our enterprise architect do then if we're going to do TDD? Who's going to draw the pretty pictures? And so this book is by Simon Brown. He was, I think, doing a workshop here on Monday. Did anyone go to Simon's workshop? Oh well. So this is a LeanPub book. It's called Software Architecture for Developers. I think it's a great book. It's well worth a read. And he talks about low impact architecture. So not heavy duty UML, not heavy duty use cases, but basically the sort of stuff we do on the backs of envelopes. Boxes, lines, thinking about what's going to interact. If you go back in time through the agile literature, you'll find something that was popularized by a woman called Rebecca Wirfs-Brock back in the 90s, 80s or 90s, called CRC cards, which is about contracts, collaboration, and it's a way of essentially role-playing your class structure. Anyway, great book, and just for you, I pinged him before we came in, so there's a discount code which is valid for the next 7 days. I was hoping he was just going to give me, a word that you could write down, but apparently that's not how LeanPub works. So it's going to be case specific. Come and speak to me afterwards, or I'll tweet it later. So if you want to get it for $5 off or something like that. Recently, a guy called, I can't get his name right, Haim Maccabee, when I say recently, in the past 6 months, he's been tweeting and blogging about what he's calling adaptable design up front. Now, the thing that Agile, well, one of the things that Agile was reaction to was what's been characterized as big design up front, where you write 2,000-page specification documents over a 6-month period and then throw them over the fence, wait for the developers to turn something out in 18 months and then expect it all to be hunky-dory. And so we went to user stories and very test-driven, low-weight design, emergent design principles. And I think Haim's got, for my money, he's got the wrong end of the stick. He's going back to saying, well, we should really know more about it before we start and design it so it's adaptable. I think the problem that I have with his approach and that I'd just like to mention in passing is that we don't know what levels of adaptability we're going to need. The way Agile works essentially is that every week or 2 weeks, your product owner can change their mind. That's the deal. That's what we say. Don't speak to us for a fortnight until we ask you questions, unless we ask you questions. But at the end of the sprint, you can prioritize whatever you like, and we'll change direction, and we won't have wasted any time. And if you're designing things up front because you know something's coming, well, then you've wasted that work if it doesn't come. It's in the XP world, it's being characterized as Yagni. You ain't going to need it. And it's also known as gold plating. So it's context dependent. There are sometimes, for instance, if you are rewriting a system for a large telecoms provider and you've got to support hardware from 6 different vendors, you've supported those 6 different vendors for a decade, you're going to have to support them when you go live, then it's at least worth thinking you're going to have to support at least 2 different vendors, and so you have to design some pluggable adaptability in. But in general, 1 step at a time, 1 story at a time, 1 test at a time. Bears. So I hope you don't mind. There's a lot of pictures of books that are littered throughout this session. For my money, I find that almost everything I ever think of has been thought about and written about by somebody else before. So I've only picked the books that I like. I've got an attic full of books. I would say 80% of them I've only touched and just not going to read it. So the ones that I'm putting up here, I've read them and I think they are world-class books, well worth reading. So this one's called Waltzing with Bears, and it's written by Tom DeMarco and Timothy Lister. So you've probably heard of Tom DeMarco. He wrote Peopleware back in the 90s or maybe even the 80s. So him and Tim Lister have written a lot of books together, and again, they're very incisive and wonderfully written stuff. Waltzing with Bears is a book about managing risk on software projects. You remember we talked about, at the beginning of the session, I was mentioning that unit tests give you confidence that your software is going to work, and it's context dependent. And so the other side of that is, of course, you may want to be able to take risks. The joyous thing that they say in the first chapter of this book is that if there's no risk on your next software project, don't do it. Why do we write software? We generally write software to deliver some value to the customer that they haven't got at the moment. And there's always going to be some risk involved there. We don't know what's going to happen. There's a risk. So this is a great book that goes through and examines risk and how to deal with it. It's got a lot of good things to say about estimates. So how many people here are regularly asked to give estimates for how long things will take? How many people like doing that? How many people think they are accurate doing that? Right, so we've got this huge problem, haven't we? Because we continually get asked to give estimates. Very rarely do we have the business knowledge to know why we're being asked to give those estimates. I can count on the fingers of one hand. In fact, I can count on a hand with no fingers the number of times the business people have told me how valuable the thing they're asking me to estimate is. So they want to know how much it's going to cost, but they're not going to tell me they're not even going to think about how valuable it is. And it's 2 sides of the same coin. So they're going to ask us for estimates, and the joy thing that we get from this book is that he makes it very clear that what we normally give is what are known as point estimates. And here it's not story points, it's March, Monday, 4 hours. Things that are very definitive. Whereas in fact, you're estimating something you haven't done. You don't know how long it's going to take. People that have done macro studies of projects that have been delivered over many years have found that it takes between 50% of the estimate to 400 times the estimate is your average, span. So from half to 4 times the estimate. Now, if it's a 6-month project, it could be 3 months or it could be 2 years. That's a big difference. So what they suggest is you never give an estimate of a date or a time. What you say is, I think it'll be between 2 points, and you give within a 50% possibility. Now that's hard to do, and your customers won't love you because the top end of that estimate is going to be way, way longer than they expected. However, how many times have you had a project overrun? Mostly they overrun. I mean, very few projects come in under budget. No, maybe I should ask that question. How many people have had a project come in under budget? Just the ones, okay. So it's not likely. Probability said someone had to get one in, so that's good. But in general, they come in over. So wouldn't it be better to be honest with them? and let them know that there's really a great deal of uncertainty. And in fact, another wonderful blog by a guy called Alan Kelly it's an open letter, and it's called the Dear Customer letter. And it just lays out for your customer in customer terms why we can't be precise about it. The other thing that I think we should observe is that very rarely when you finish a project do you all get together and you go, you know, that's absolutely the way we should have done it, right? Because it's not, because we know a lot more at the end of the project than we knew at the beginning of the project. A project is, in fact, a journey of discovery. You're learning stuff about your domain, you're learning stuff about the technology. And so as time goes on through the project, you learn about how you would want to do it better, or how you might do it if you did it the next time. And in fact, that's also been characterized as the, what do they call it? They call it the cone of uncertainty. It's not quite like ice cream, but basically, the cone of uncertainty looks like that. It says at the beginning, if there's time going along this axis, at the beginning of a project, we know nothing about it. The chances of us getting an estimate correct are really very low, so we have to give a very wide estimate. But as the project gets more and more developed and we learn more and more about it, our knowledge becomes much better, our understanding of what needs to be done, and so we can give much tighter estimates. And this is why agile methods use story points for small stories, because once you got it down to something that's really small, it's quite easy, or at least it's easier to know how much work is involved. So when you think about big things that are a long way away, that it's problematic. Which reminds me of that sketch in Father Ted, when he's in the caravan with Dougal, and Dougal just can't work out why is, I've got this small toy cow here, and there's a real cow out in the field, but they're the same size. Father Ted's going, Dougal, this one's small, that one's far away. And it's the same sort of problem that we've got with estimating things. So a feature that says we're going to have a funky website will deliver loads and loads of stuff, it looks small because it's a long way away. And it's only when we get closer to it that we find out, oh, I don't know anything about OAuth. So there's risk. We want to mitigate that risk. We want to make sure that what we deliver is what the customer wants, and that it works, and it works according to their context. So if we tested everything, maybe that would be very expensive. Should we test everything? So this is a really high definition slide done by Dan North. So Dan North is one of the thought leaders, I guess, in the agile behavior-driven community. Was he at this conference? Must be one of the few that he's not been at. But so he's found this new way of doing slides, which is he does them on index cards, then he takes a photo of the index card. It's great. And so here he's got a graph of the impact of a problem and the likelihood of a problem. So basically what he's saying is that you've got functionality in your system. If some of it goes wrong, it might have a big impact. So if you're a bank and suddenly all of your accounts lose $1,000, then that's a bad thing. But if you're a shopping website and a button is the wrong shade of puce, maybe it's not such a big impact. And there's also the likelihood of this problem materializing. So are we going to have this problem? Well, if it's something that's new, it's risky, it's based on technology that we haven't really got a handle on, then it's very likely. If it's, I just have to draw a widget on the screen, or maybe I have to access a table in a database, maybe it's not very likely. So there's two axes on which you consider whether the work that you're doing is high risk or not. And then he suggests we think about how these things fit together. Should we test this stuff really extensively? Or should we test this stuff really extensively? And, it's a no-brainer, isn't it? You want to test the high impact, high likelihood stuff because that's the stuff that your customers are going to care about, and that's the stuff that's most likely to go wrong. But he says, well, what sort of level of testing do you want? Because testing is quite often, considered in terms of code coverage. Are people familiar with code coverage as a metric? Okay. So code coverage actually, by the way, is a terrible metric. More of that later. But 80% is actually quite high code coverage. Most systems struggle to get 80%, even though some people demand 100. But the question is, 80% over here, that feels like overkill. But 80% over here, that doesn't feel like enough. 20% of your code might not be tested, and it's got a high impact when it goes wrong and a high likelihood of going wrong. So again, it's more context stuff. We want to think about what's the context of this component being used before we understand how aggressively, what level of confidence we want that it's going to function. So Dan's talking about this. So essentially what he's saying is, well, maybe we can do without unit tests here. And at this point, my alarm bells start ringing, okay? Because I don't know about you. You're here at the DevWeek conference, so you're probably all coding gods anyway. But most people I go and speak to have difficulty understanding which bits of their system are more likely to fail than others, and which bits have the biggest impact. And I struggle to get people to write tests anyway. And to give a sort of get-out clause that says, if it's low impact, low likelihood, don't write any tests, that worries me. So I had a rather public argument with Dan about this. I didn't come out well, actually. Because, he rather took the huff. But I was pointing to this entry in the C2 wiki, which is one of the wikis which is the home of Agile. So it says, code may not be released unless it is formatted to an agreed convention, has been coded by pair programming, has unit tests, has passed all the unit tests at 100%. Now this is XP, it's pretty extreme. I would suggest, and you can correct me if I'm wrong, but this coding convention seems to be the thing that most people focus on in their peer reviews. I've yet to go to a commercial organization where pair programming is the norm. We've already talked about unit tests, and I've already mentioned how a lot of tests often fail or get turned off. So I didn't want to make it any easier for people to wiggle out of it. But what Dan pointed me to was there's another rule, which is they're just rules. So one of the many extreme rules is if a rule isn't working, the team can remove it from the rule list, which is the cop-out, isn't it? But this is not a get-out-of-jail-free card. Okay, this is not saying if you don't like unit testing or you're finding it hard, then don't do it. In so many areas of human endeavor, there's a sort of fractal way of engaging with it. Right? It all looks very simple when you read the glossy magazine, and then you buy a 200-page book and it looks a bit harder, and then you start trying to do it and oh God, I have no idea what to do now. And it's the same with these rules. It's the same with all the Agile rules. So someone tweeted a while ago about Agile. If you're doing Agile by the book, you had better have written the book. But the corollary of that is until you can write the book, as in until you can adapt, until you can practice the Agile and understand why you're doing each of those practices within the process, don't tamper with it. So it's a process of learning more about what you're trying to achieve and then tailoring it to your current organization, rather than going, nah, don't like retrospectives, nah, don't like unit testing, we'll just do the stand-up. Which is, not dissimilar from a lot of Agile processes. So these are not get-out-of-jail-free cards. You need to at least have practiced it on your own to be confident that you understand what it is that's trying to be delivered by these different practices. And then if they don't work for you, obviously, don't do them. I would suggest that in almost all commercial organizations, unit testing is something that will deliver value, and it will deliver value very quickly. Because I don't know what your release test tail is like, but I frequently work at places where it takes 3 months for the testers to go through all of their regression test pack to make sure things aren't broken. And if you can reduce that even by a month, you're saving people money. And typically you can reduce it by a lot more than a month over time, which leads to all these wonderful continuous delivery ways of working. Anybody continuously delivering? Yeah?
More or less.
Cool. So do you have lots of unit tests?
There are different parts that we don't have control over, but the parts we have control over are unit tests, yeah.
Cool. And how often does it deliver to production?
It's either 2 weeks or 4 weeks.
And do you have a manual test phase?
Not so much.
So I mean, that's holy grail land for a lot of organisations, isn't it? Do we have any people from QA here? As in testers? No. Okay. Fair enough, I can ask them. So, back to one of my favourite bugbears. What use is coverage? So, you all said that you've come across coverage. What does coverage tell us?
Tells you that you've executed those particular, how much of it you've executed, but not obviously which bit you've executed.
Yeah, okay. So, it tells you how many, well, so there's lots of different sorts of coverage for starters. There's line coverage, there's branch coverage, there's statement coverage, there's all sorts of different things you can measure. Typically people measure line coverage and they're measuring, when you ran your unit tests, which lines of code were executed while those tests were running. What it doesn't tell you is whether you checked what happened on those lines, so you can get 100% coverage and do zero testing. The test requires you to set up a context, do something, and then check that the output was what you expected. But you can actually get 100% coverage without ever checking anything. And this is one of the problems. When your project manager comes in, from now on we're going to have 80% coverage, and each sprint it's going to go up by 2%. It's like, well, what are you as a developer going to do if your the code base that you've got is a legacy code base that's really difficult to test, and you're still being forced to churn out the same amount of stuff? You're going to game the system any way you can. And so there are a lot of places with high coverage and zero testing, or low testing. Shameless self-promotion. Mutation testing is not a new technique, but it's one that's not widely used in commercial world. This afternoon, I'm giving a talk called Mutation Testing, Better Code Through Writing Bugs, in which I will explore this in much more detail. But essentially, mutation testing is a technique which allows you to validate the quality of your test suite in a way that coverage doesn't. How many people work in Java? Not many. How many people are in .NET, C#? Most. Okay, so unfortunately for you guys, there's no good mutation testing framework in .NET. On the plus side, if you come along to the session this afternoon, you'll find out why there should be, and maybe you can go and contribute to one. There have been 3 attempts, and none of them so far have held water, unfortunately. So, competition. No one's got it so far? So here comes a clue. Maybe it's just that everyone here's too young. I don't know. Okay, well, we'll do it at the end. So I hope that I've maybe not convinced you, but I hope I've sort of given a picture of why test first is an attractive way of going. It means that you drive out the functionality, you end up with a good set of tests that ensure that it works in the way that you expect. But there are lots of different sorts of tests first. Like I said, the fractal nature of knowledge. So inside out is maybe classic TDD, where you start thinking about the low-level components and unit test them first. And then there's the outside in, which has been called the London School. So mostly actually London-based? Nope. So London has got a wonderful set of experts from Steve Freeman and Nat Price through a vast galaxy of stars, and a lot of them turn up every Tuesday night to a pub by Smithfield Market called the Bishop's Finger, and hang out and just chat and basically drink beer, shoot the breeze. And it's called Extreme Tuesday Club. And if you do a Google on it, you'll find the website that lists what goes on there. And so if you do find yourself wanting to go for a drink on a Tuesday night, that's a great place to go. But anyway, there's different ways of working. Nat Price and Steve Freeman wrote this book, which is based in Java. However, please, .NET developers, go buy it anyway. So C# and Java look remarkably similar. for the reason that is obvious, because Microsoft weren't allowed to use Java, so they cloned it. This book is an amazing book, not just about growing object-oriented software guided by tests, which is what we're talking about all today, but because it talks about a design methodology and philosophy that fits well with object thinking, fits well with statically typed object-oriented languages like C# and like Java. Yeah, I think it's a fun book as well. It's a good book to read. And so you remember the red-green refactor diagram that I showed at the beginning of this session, or earlier on, that's TDD. Well, that was drawn by Nat Price as part of this book. And he then went on to demonstrate how he sees software development working. And this is starting with end-to-end tests. So this is sometimes characterized as acceptance test-driven development, or behavior-driven development, or specification by example. And you're thinking about how the system is going to behave from the point of view of something external to the system, whether it's a user, another web service, your ops people, and you express a test or a specification in terms of the behavior that you want the system to exhibit, and that will fail because you haven't done any of the work in the code level yet. Then you go into your classic TDD loop where you'll write maybe many failing tests to get this complex behavior to work. You go around through this loop many times, and then you pop out the back and you find, oh, it's green. Now, there is another step, essentially, which is the mirror image of this refactor, because as you go through writing these end-to-end acceptance tests, you begin to find new behaviors, you want to express it in different ways, you discover other domain concepts, and you boost it all up. We're not talking about this today. I'm definitely still going to carry on talking about the unit test, the developer test layer. What is a unit test? I shouldn't really put that up. What is a unit test?
Sorry, I've got a question. Maybe.
Yeah, sure.
In this diagram there,
yeah,
where would be the exit point? Is there an assumption there that this is an endless process?
So that's a great question. The exit point is whenever your customer is ready, is happy that what you've written is what they want. So you keep going around this until they go, that's as much functionality as I want. So the holy grail of agile working is that you cut your stories down to really thin slices, and you go around this loop quite quickly, and every 2 weeks or every week, the product owner or the customer gets to choose what you do next. And one day they come in and go, actually, that's all I wanted. Done. So that's not typically what happens. What typically happens is they go, I want some more. And so as a software provider or as a development house, you want this to go on forever because you're going to be delivering them value. They're going to be using that value to make more money. They're going to think of new things that they can do. They're going to ask you to do more things. If you're an in-house service where you're trying to satisfy some business goal, maybe you've got different motivations. What you want to do is, please be satisfied and go away. But either way, it's the customer who tells you when you're done. It's the customer who tells you when to leave.
So what about within the 2 weeks typical iteration?
Yeah.
I guess because refactoring doesn't have any kind of clear metrics or in terms of when can one stop.
Yeah.
Is there any risk of that actually taking over its own life and consuming time?
So I guess it's a fear that many people express. I don't know what your feeling is, but my guess is that most developers actually do want to develop code, and what you want to do is you look at it and you say, this is messy. It's going to make it harder to develop code, so I need to tidy it up with refactoring. It's like paying back technical debt, but it's not something that I think as a developer I get stuck into and go, I'm having too much fun refactoring. I'm not going to write any code. So I'm not sure it's a concern that ever really materializes in reality. Do you feel that if you were allowed to refactor at will, you would just never stop?
I have seen examples on
yeah,
when that refactoring became an obsession sometimes.
So that's an interesting place to be, and I have to admit I've never been in a situation where I've had to stop people from refactoring. I've quite often been in a situation where I'm going, oh, please, God, move that. Don't let that duplicate. No, why did you cut and paste that? Why have you cloned this whole hierarchy? Why have you added another depth to this hierarchy? So I find that quite often the developers that I've worked with aren't spending enough time thinking about the design and what would be clean. Quite the opposite of what you've just described, which is always going, oh, maybe I should use this other new funky pattern that I found over here. So maybe, I guess, it's true. I have seen some places where people have sort of pattern envy, and they've been reading the design pattern book, and they go, oh, I haven't used that pattern yet. Where can I use that? And so, there are scrum masters or project managers or team leads who have to exercise some control around that.
I think there can be a danger with refactoring where people don't understand what the code's really doing, understand the tests. So they think they're refactoring it correctly, but actually they're not.
So there is an issue there, and so I think there's two issues there. One issue is around if you don't understand the tests, and the tests themselves have been badly written, because the whole point of tests is to document your specification, your design. And the other is, if you refactor it badly, then you'd hope that the test will break. Actually, there's a bit that's coming up from somebody else who talks about how refactoring should fit in and when you should stop there. So let's park it for a little bit, and if there's still some issues when we get to Ian Cooper's little rant about unit testing and refactoring, we'll take it up there. So jumping back a bit, what is a unit test?
Black box test.
Yeah.
Self-contained test.
Self-contained. Super fast.
Single class.
Sorry?
Single class.
Single class. Okay. What sort of tests aren't unit tests?
Once they hit the database.
Ones that hit the database.
Well, anything with hitting an external.
Anything hitting an external system. Have to change in configuration. So this is a list that was put together by Michael Feathers. Has anybody read his book, Working Effectively with Legacy Code? Do any of you work in systems that are older than a year? Do any of you work with systems that don't have really good unit tests to document how they work? You're working with legacy systems. You need his book, because it's just a tome of wisdom. The poor guy spent 10 years putting legacy code bases for customers under test. His marriage collapsed. He's not the happiest guy in the world, but he's learnt a lot, and he poured it all out into that book. The least you can do is buy a copy. So it's a great book, but here you go. It talks to the database. So this is what this gentleman said, and it's really to do with external systems. So if you've got databases involved, if you've got networks, if you touch a file system, if it's got contention with other tests, so you can parallelize it, or if you had to tweak with the environment. These are not unit tests. They may be very valuable tests. They may be integration tests that deliver value. They may be end-to-end or system tests that deliver value, but they're not unit tests. And the reason there's a distinction is that unit tests have to be blisteringly fast. There's this wonderful testing pyramid that gets used a lot to describe this. And it's a shame because it's a triangle, isn't it? But there you go. It's got two axes. This axis I characterize as being the depth of the application stack, or the breadth of the application stack that the test exercises. So down here, we're only testing maybe a method or a couple of classes working together. And as you go up, you start testing, you're more exercising protocols, the interaction between components, until you get to the top, where you have end-to-end system tests that may go through the UI or the web service layer and go all the way through to the database and out to the network into test services and things like that. And the breadth, the width of the pyramid describes how many tests. So people ask me how many tests. It's not how many tests, it's just there should be lots of unit tests. They're your foundation. They're the thing that make sure that the code you write works correctly. And these tests begin to start moving towards making sure that it does what the customer wants. So these are to do with features, and this is to do with function. And never to be forgotten, is that no matter how good your automated testing gets, there's still a place for a skilled and dedicated QA person in your organization to do exploratory testing, things you didn't think of, checking out what happens when you do SQL injection, things like that. However, this is quite often not what I find as being the distribution of tests in customer sites. One famous anti-pattern is called the ice cream cone, which essentially is this is really fat at the top and this is really thin, where you have hardly any unit tests, but loads and loads of end-to-end system tests. It can be okay, but typically these are slow, these are brittler than these are. They're not things that always can run on developer desktops. It just makes it harder to develop. The other common anti-pattern that I see, I call the beer belly testing pattern. And that's where you've got hardly any of these, hardly any of that, but you've got a great big bulge out here. And these are where people are very, very closely coupled to the database often. And they need a database to run any of their tests. So essentially what that tells me is they haven't got persistence, they've got no interface to the persistence layer. What Michael Feathers talks about in his book, Working Effectively with Legacy Code, he talks about seams in the software. Seams at which you can introduce test entities. So instead of using a database, you use a test source of objects. And we'll talk a bit about that later. So these tests that verify components in isolation. So if we think about a car, we're talking about the low-level components that make up a car, brake cylinders, the lights, the ignition key. Then we move on to the integrated components, the subsystems, the whole cooling system, your engine, your steering rack. These are big assemblies of multiple things, and what you want to do is not test that the brake cylinder works, but test that when you put your foot on the pedal, the car stops. And that's a much more complex interaction. Then up here, you've got your automated tests on a rolling floor or something of that nature. And in the exploratory world, you still load them up with test dummies and see what happens when you actually crash the car into a brick wall. So now it is time to talk about Ian Cooper's talk. So Ian Cooper is, again, I think another Londoner who's been doing this talk on rebooting test-driven development. And the main point that he's making is that a lot of the unit tests that get written today are testing the implementations, making sure that the list is in the right order, or that it fills memory correctly, or that it's got the right performance profile, rather than expressing behaviors about how you want your component, how you want your class to actually work. And so I think this comes down to the refactoring discussion, at least it's part of the refactoring discussion. When we refactor, we don't want to break tests. This is important. So what we're trying to do when we refactor is improve the structure of the code. But I think what is often forgotten is that the definition of refactor is two-part. It's improving the structure of the code without affecting the externally observable behavior of the code. And if we are testing things that aren't externally observable, then maybe our refactorings are going to break the tests. The whole point about the refactoring cycle is that once you get to green, you can refactor and run the tests and they stay green. Because you want the test to give you confidence that you haven't changed how your code's working. So this is what he's saying is our tests are now knowing too much about the implementation. And so because they're too tightly coupled to an implementation or implementation details, then when we change that implementation, it breaks the tests and we have to rewrite the tests. And as soon as we have to modify the tests, we're not refactoring. As soon as we're modifying the test, we're changing the behavior of a component or a system. And so he claims that that at this point, the tests are over-specified, or the system is over-specified through the tests. And I guess the payload here is, instead of assisting change, our tests have now begun to hamper it. And this is what we really want to avoid. Our tests are there to help us. We would like our tests to be things that we love and cherish and keep in good condition and make our life simpler. Whereas in this situation, you don't want to change the code because you know that the tests are going to all break and you're going to have to go and fix them all. that I worked at many years ago, they had a wonderful suite of tests written in their own in-house scripting language that exercised the system. And it was great because it was quite a complex system and there were no unit tests, so these integration tests essentially that ran in the scripting language were all we had. We pressed the button, we knew it worked. And then of course, we upgraded a major version number, all the interfaces changed, all the tests broke. I went back and worked there 10 years later, they'd never run again. And this is the problem that we risk moving into. So we need to write our tests in such a way that we can make significant changes to our system structure without breaking the tests, or we need to be able to make sure that we can refactor the tests and then refactor the code. And there are lots of ways of doing that. One of your biggest friends, which I'm not going into in this session, is something called the builder pattern, which is covered in detail in that book, Growing Object-Oriented Software Guided by Tests. And the builder pattern essentially says, my tests know nothing about how to create any of these objects. I'm delegating creation of objects to some external agency that I'm going to create, and any modifications that I need to make to constructor methods or setting up, making sure that this customer is a smoker or a non-smoker, all that's going to be delegated away. My tests deal at the abstract level. And that makes it really simple. When you decide that your customer you don't just say whether your customer is a smoker or non-smoker, but you say whether they're male or female, and you say what postcode they live in. You don't have to go through all of your tests, changing the code to create a customer. You go to your builder and say, by default, all my customers are going to be female and they're all going to live in Northwest 1. Because for most of your tests, it will be an incidental detail, what gender they are or where they live. And then for the tests, where it's not an incidental detail, because I guess you introduced the gender and the address because your system needed to know about it somewhere, then you specifically say in that test, okay builder, create me a customer, but this time I want a male person that lives in Cumbria. And then you can do your testing like that. So the builder pattern is really powerful. If you do a Google search, you'll find that there's a number of versions of a talk that I give called Bad Test, Good Test, which goes into a lot of detail about what I believe a good test should look like. And this is the one slide version of that hour-long talk, which is that unit tests should be understandable, as in people on your team who read the test should understand why they're there. So I've sat with people and asked them to explain a test in their own code base, and they've said, oh, actually, I don't think I wrote this one. So that may be true, but it shouldn't be there. If you can't explain it, then it's not documenting what the system does. If it doesn't document what the system does, then when it breaks, no one's going to know why it broke or what to do about it. So when a test breaks, what does it mean? Does it mean that the test is wrong or that the system is wrong? Well, we don't know, unless you can understand what the test is trying to test and compare that to your requirements. This builder pattern that I was talking about is in the space of maintainable. We want to make sure that our code can evolve and our tests don't die when we evolve the code. Repeatable is a problem that does happen a lot, which is, oh yeah, that test doesn't work on a Friday, or it only works when I kick it off from my desktop, or sometimes it fails but we're not sure why. We don't want that. Our unit tests have to be 100% repeatable. So sometimes you can live with integration and end-to-end tests that are a little bit brittle, simply because if you're testing a huge system and there's some external service and it goes down for reasons that are beyond your control, well, there's nothing that you can do about it, but it may still be more valuable to have that test. But at the unit test level, they should be 100% repeatable. You should be able to run them over and over again. They pass every single time. And that actually pulls into your continuous integration server. So I hope you're all running continuous integration servers. If not, then maybe give it a shot. But the idea there is that you test it on your desktop and then you check it in, and the CI server builds it from scratch with anything else that's been checked in since the last time. and then runs all the unit tests, and then tells you if it's failed. And when it fails, you want to do something about it. But if the tests are not repeatable, if 2 or 3 times you've looked at it and you run it, oh, it passed it this time, you're going to stop caring. And there's nothing as useless as a continuous integration service that nobody cares about. So the rule of CI is that when the CI fails, the highest team priority is to get it to pass again. No questions. I mean, it doesn't mean that everyone has to stop, but it's like, jeeps, it's failed. Who's going to fix it and get it fixed? Because you shouldn't ever check in on top of a failed build, because now you've got 2 problems, potentially, or more. Necessary is slightly less easy to explain in a one-slide sort of thing, but essentially, over time, some tests become superfluous. There's also something in TDD called triangulation, which again, I'm not going to spend the time on just now, which means that you might write extra tests while you're driving out functionality. So this is shorthand for saying it's okay to delete tests if you don't need them anymore. Granular is about keeping tests small and focused. So for my money, a test should explain its purpose in life in its method name. And if you find that method name goes over 30 characters, 80 characters, 130 characters, you start writing an essay, your test is too big. If you find it's got a conjunction in it, like and, it's too big. A rule of thumb that I use, but often abuse, is it should only have 1 assertion in the test. Now, that's not a strong rule, because there are times when a particular behavior has a number of different outcomes, and at that point you may have more than 1 assertion. But basically, it's keep them small and focused. And then fast is the final one for obvious reasons, because we want to be able to get the feedback really quickly. We want our Crunch or whatever to run those tests as we type. We want the continuous integration server to fail fast so that we can fix it before anybody else wants to check in. So these are 7 properties that I just described good unit testing with. Roy Osherove, in his first book of X-unit test patterns, identified 3 properties. His were maintainable, trustworthy, and readable, which sort of fit in. A lady called Emily Bache, who's British but lives in Scandinavia these days, she has written a book called The Coding Dojo Handbook, which if you want to do Coding Dojo is a great resource. And she identified 4 properties. She calls them coverage, readability, robustness, and speed. So Roy had 3, Emily had 4, I've got 7. Thought, yay, doing good things. Roy's working on the second version of X-unit test patterns. It's up to 9 now. So I've got, yeah, there we go, we've got a way to go. So we need to think about testing these components in isolation, because they can't be unit tests if they interact with everything, and so somehow we need to isolate them. And at this point we need to design for testability. And this, I think, is the reason why so many people who try to write the tests after they've written the code have a problem, because although it's entirely possible to write the code in a testable way and therefore write the tests afterwards, you really have to think about how am I going to test this as you're writing the code. So why not write the test first and then let that drive you? So one of the things, two of the main approaches to trying to make sure that your code is isolatable is this inversion of control or dependency injection. Now, who uses a dependency injection or an inversion of control framework? Okay, so those people that put their hands up, is it frameworks that you're using, or are you doing it as part of your development? In code, are you actually making sure that you pass your dependencies in by hand to your constructors? Bit of both. So the thing is that inversion of control, dependency injection, is a very simple technique. And like so many simple techniques, it has been made somewhat more complex. This is a great blog post. James Shaw wrote this one, Dependency Injection Demystified. And essentially, he describes dependency injection from first principles and then goes through 2 or 3 iterations to show how the dependency injection frameworks like Spring and Pico Container and all of those, I'm sure there must be other ones in .NET land. What are the .NET ones? Autofac, okay. So that's why these have come into existence. So interesting to read. And since I mentioned James Shaw, I think it's time for a humorous picture. So James Shaw wrote Agile Development, or The Art of Agile Development, it's actually called, which is probably the best book on Agile. But he also did a great book, a great blog post called Continuous Integration on $1 a Day. And it uses a plastic chicken and a bell. So again, a very interesting blog post to read. One of the things, once you start doing dependency injection, is that you find that you then need to create some sort of test component to inject, because the idea is you want to isolate it from the real ones. So whether it's a database or some calculation engine or some external service, you want to inject something that conforms to that interface but does what you want it to do, so that you get the tests, you get the input to your tests that you need for the particular behavior that you're specifying. And at that point, people start talking about mocking. Now, is there anybody here who's never used the word mock in technical terms? The trouble with mocking is that it's, in the same way that dependency injection has gone from something that's very simple, and now everyone thinks of big frameworks. Mocking has gone from something, mocking's gone the other direction in a way. Mocking was created, were frameworks that were created to make some rather complex things simple, and now the frameworks get used frequently to do simple things in a complicated way. And so, mocking in a nutshell, I'm not going to go into a great deal of detail, but I was thinking about how to describe this. And I think the first thing to observe is that nutshells are a movable feast. The first edition of Java in a nutshell came in at 400 pages. The 5th edition came in at 1,228 pages. So it's not the same nutshell. And the same is true of mocking. Mocking is around trying to create an instance, something that implements your interface and behaves in a way that you want it to do in your test. So for instance, if you've got an external service that the component you want to test is using, and you want to test what happens when the service goes down, or when it returns badly formed data, then you don't want to go and fiddle with your external service. What you do is you provide an implementation of the service's interface that gives you a failure exception, or passes back the wrong data. And then your test can assert that your component behaves in the way you expect. That doesn't need to be a mock. Okay? A mock is typically it's a framework that you declaratively say how you want it to behave in certain situations. So a guy called Gerard Mezaros, who wrote, if that's the right way to pronounce it, I'm not sure, who wrote XUnit test patterns, has a taxonomy of the different test doubles that he uses. So this is the important thing, that what we're doing is we're talking about injecting test doubles. So it's something that behaves, that conforms to an interface, but it behaves in the way that you need it to behave to test a specific behavior. So he talks about dummy objects. So these are ones that you just need to pass around to conform to an interface. You don't care how they behave, because in the behavior that you're interested in, they're never going to get used. So the simplest dummy to pass around is often null. You just pass the null in. Fake is when you actually want it to do something, but you don't want to use the real world stuff. So if you've got complex calculations, if you've got an external web service, you can sometimes use fakes of that. Stubs are quite focused. They provide canned responses. So a stub, you'll say, provide this response whenever this method gets called. And the mocks are around dealing with behaviors. They're much more explicit, they're much more complex. So your mocking frameworks, you'll be able to say, well, create me a test double for this interface, and when this method gets called with these arguments, then return this. But if it's called twice, then fail. Or you might say, you need to call this method on this object, and then this other method, and it's going to have these arguments. And you can make them arbitrarily complex. And that means you can make them infinitely incomprehensible. And that's unfortunately what happens a lot. So when people talk about mocking, it's worth understanding whether you actually are interested in behavior or whether you really want stubbing. Now, it's not to say that you can't use your mocking frameworks to create stubs, because obviously you can, but don't use them in anger. Don't use them to over-specify. So we're back to what Ian Cooper was saying about over-specifying your tests. Your mocking frameworks allow you to specify what parameters should be passed to your methods. So you can say, if this method is called with a string of value Seb and an amount of money, £10,000, then return repeat. Okay? You can do that. But if in fact you just want to test that if any non-zero value is passed in to any person, they're always going to say repeat. Don't specify Seb, because it's irrelevant. It's not part of the contract. So this is about trying to ensure that you don't put incidental details into your mocks. You want to keep your mocks as loose as possible, because we don't want to over-specify that test. So mocking can give you this false sense of security, and I notice I'm running out of time. So I might go a little bit faster. The trouble with mocking is that you set up these mocks and everything works fine. You think, great, but what happens if what you've mocked isn't how the system behaves? So your mock actually isn't a faithful double of the actual system that you're trying to test. And at this point I bring in the guy called JB Rainsberger, who did this excellent posting about contract and collaboration tests. And what he essentially says is that, I think I'll move on to the other page in a second, but you need a systematic way to check that your code remains in sync with the implementations of the component you're mocking. So basically, you can keep changing your code, and if the mock behaves in the way it used to, your tests keep passing. But if the actual implementation that you're mocking then changes, well, how do you know? How do you make sure that your mock stays in sync with it? And his proposal is that you have to, whenever you change an implementation of something, you have to notice the change in the contract. So whether you change it in your contract tests, which verify that the external system works the way you want it to, or whether you notice it when you're changing your tests themselves, then for each change, you have to essentially make sure you make a matching change in the other package of tests. So we essentially have two sets of tests. We have the contract tests, which verify that the component behaves in the way that you expect it to, the external component, and you have your collaboration tests, which use mock or test double versions of that component. And those collaboration and contract tests, it takes discipline, but you have to notice when you change either of them. The benefit of working in this way is that your contract tests are a really, really good way of making sure that when your external provider gives you a new version of that component, it still works for your software, because you will just run your contract tests against the new version for your upgrade. We mentioned Bob Martin, and this another great book, but we'll pass over that. So Bob Martin blogs on a site called 8th Light, who I believe are just opening up offices in London this year. And so he asked this question, you know, if all your production code got deleted, but you had backup of your tests, you know, would you be able to recreate the production system with little work? But if your tests were deleted and you still had the production code, how would you be able to evolve the production code? So he's basically saying, if it's a choice between saving the tests or the production code, save the tests. Now, I hope it's not a choice you ever have to make, but essentially that's how important the tests are. They are what communicate to developers how the system works and verify at a regression point and check-in time that the system still behaves according to the specification in a way that comments can never do. Because, you know, I'm not even going to ask you to put up your hand, because if there's a single person in this room that can claim to have read a comment that has never read a comment that was incorrect, I would scream, because it's just not true. Comments get cut and pasted all the time. So, don't panic. Software is easy to write, but it's hard to write well. Just like so many other things. It's easy to write a shopping list. It's harder to cook the stuff when it comes back in. Things are more complex than they look like, and practice is the way to get better at doing things. especially practice when you read books, you get ideas, you try them out, you see how it works, you bounce ideas off colleagues, you work together. So we shouldn't panic, but we should be aware that a lot of things are not being done well. I mean, I'm sure you feel the pain in your organisation when you go into work and things aren't exactly the way you want them, or the way you'd like them to be. I'm sure you think to yourselves, there must be a better way of writing software. And I believe that test-driven development is a part of that better way. However, as I said, practice is the way to go. Now, Cyber Dojo is a tool that a colleague of mine called John Jagger has put up. It's on the internet. It's at cyber-dojo.com. I believe at the moment it's down, but it's down because he naively put it up without any security. And so it's been running for several years. And what it does is it allows you to either on your own or collaboratively as a group of people work on small example problems, which are known as katas. And it's an online environment, so as long as you've got a browser and network connection, you can access it. And it's got about 20 different programming environments currently enabled in it, from Java and C# through to Erlang and Haskell and stuff like that. And it's really, really useful, because it just means that if you're with your mates, I don't know what sort of mates you got, if you're with your mates and you want to practice a little problem, it's got a library of 20 or 30 different katas. You can pick a programming language, you can all fire it up on your machine, you end up with a practice ID for each kata, and you can all work on the same kata in parallel. I mean, you've got your own code repository, you've got your own version of the code, and then after half an hour or an hour, you can then bring up the review page and you can see how everybody else can be doing. You can see the red and the green traffic lights, you can go back through time and see what every commit looks like. And all the problems are very small. So it's a wonderful way of practicing things and just honing your skill when you've got a new technique that you want to work with. It's just a web browser with an edit box in it. So there's this FAQ that he's put up about it, about lots of questions. People say, well, why doesn't it do this and why doesn't it do that? And all the answers are the same. So it's there to practice, okay? So I encourage you, he's claiming, so this is an estimate, so I wonder if it's an accurate estimate, he's claiming it'll be back online on the 9th of April. So it's not far away, so go and try it then. And at this point, does anyone have any clue what the book was?
Scorpion?
No? Well, I'll put the slide up and then we'll see if anybody knows what this book is. No? Well, there you go. It must have been a cult that I was a member of when none of you were. There you go. So this was a major book in the 70s, apparently. I didn't read it in the 70s, but it was a major book in the 70s. Other major books, there's a major book that's coming out this year. It's called the Cucumber JVM book. It's written by me. So hopefully it'll get published this year. So if you're working on the JVM, which it sounds like you aren't, then this would be a great book. After this one gets published, I'm then slated to work with a guy from SpecFlow to do the SpecFlow version of this book, which will probably be more in tune with the .NET folk. So the things that seem important to me, the takeaways that I hope you've at least got a flavour of, is that we're after delivering value to the customer, which is after delivering value to our business. So that's what we're doing. We're specifying what the system should do. We're specifying it using tests that are maintainable and fast. We need to think about the risks that we're trying to address. So we don't go crazy, we don't write tests forever, we don't refactor forever. We have to address the risks and make choices and trade-offs intelligently. But we need to understand what our context is. So are we working in mission-critical stuff, or do we need to get stuff out fast and to hell with the consequences? So in short, the tests should make your life easier. If they don't make your life easier, then something's wrong and we need to go back and revisit. Thank you very much. And like I said, I'll be here at 4 o'clock this afternoon doing a mutation testing session. I think it's lunchtime, but if you've got any questions, please fire away.
A question.
that
Yes.
showed behaviour. And then looking at your slide about differences between mocks and stubs and what have you, do you have any comment on the lifetime in terms of the development process that these artifacts should hang around?
So I think even the assertion that you should delete your scaffolding tests might be questionable. So in a lot of cases, those scaffolding tests, you would run them in a separate test pack, but I'm not sure you necessarily want to delete them. You may not put them in your CI build, you may not have them straight away for all of these areas, but if you want to go and refactor something very in a targeted way, then I think those scaffolding tests actually document how that subcomponent works. But larger than that, no, I don't have a comment on how they should, where they fit into the life cycle. Essentially, I see them as writing specifications of how the code works. I think they should live as long as the code lives. How modulo, the necessity aspect. So you remember I was saying that it's fine to delete tests if they're not necessary. So I think, I'm not sure who it was who's making this, did the talk yesterday, but when they're talking about scaffolding tests, I think they're saying once you've got delivered the software, they're no longer necessary. And I think you need to think carefully about that. Who was it, by the way?
Chap, Ralph, someone.
Ralph. Okay.
But it just made me, it sounded a very dangerous thing to do.
Yeah.
Invest a lot of time in it. If you had to go back
Yeah.
and fix a problem in one of those smaller areas.
Yeah, no, I agree.
Suddenly your knowledge is gone.
Yeah, no, it doesn't sound right to me. I understand where he's coming from, and I think he's in the same sort of space as Ian Cooper is, which is we don't want to, it's the externally observable behaviour that we're interested in. But the thing is, that externally depends on where you're looking from. So there's the external from the customer point of view, but if you're just working on a subcomponent deep down in the bowels, then externally is the rest of the system using you. And at that point, the scaffolding tests are what enforces the behaviour of that internal component.
One of your slides was about how tests should be coupled to implementation details, almost very fragile.
Yeah.
But that strikes me that that's a symptom of a bad test, because the test should be looking at the public interface
Yes.
of your classes,
Yeah.
and so you should be unaware of what's happening inside.
Yeah. So the slide I think said they shouldn't be.
Yes.
Yeah.
But I mean, it seemed to implying that it was valid, or there were circumstances where you are being tied to implementation details. But it strikes me that's just fundamentally the incorrect thing to be doing.
Yeah, I agree. So, however, that's still a lot. I'm not wanting to point fingers or anything, but when people write tests after code, they quite often look at the code to help them decide what test to write. So they look at, oh, there's an if statement there. I need to test both sides of the if. But that's what I mean by getting tied to implementation details. So you're still going through the public interface, but with an implicit knowledge that there's a list on the inside, or a hash map, or this sort of branching that happens at that value. Whereas you should be expressing your tests in terms of, it should behave this way if you've given said £10,000, but this way if you've given them 9,999.
Yeah, just a quick question about acceptance tests.
Yeah.
Are they majorly different from unit tests? I mean, are they more top-level tests?
Yeah. Yeah, typically when you talk about acceptance tests, you're talking about you're talking about system or component tests at a higher level.
So they don't need to be mocked and things like that. These are going to test the whole sort of layers.
Well, not entirely. So I mean, let's be clear about this. These are just words. The unit test, we've got not a very detailed definition of, but at least we've got a definition. An acceptance test depends on who's doing the accepting. So some acceptance tests will be system end-to-end tests. They'll use the whole system. They won't have mocks. But some system tests, even then, some of them will use test versions of your services. You may have acceptance tests at the component level, where you want to have specifically faked external services or databases. You may not want to interact with the database to set up all the data. So one of the main issues that you see in a lot of organizations when they want to do testing, they need a lot of data in their database. And yet you've got a lot of tests and you want to get a clean set of data each time. So you have immense problems trying to make sure that the tests run in a finite amount of time, but also you start off with clean data that doesn't have interrelated links. So at that point you might have integration tests that actually do use a stubbed out database, a stubbed out data lab. So it's not a clear-cut thing. Sorry. Let's do lunch. Thanks, guys.